everyone, welcome back to Learn With Me. I'm Deborah Hansen, and today we're going to do part 2 of 3.9, Social, Cognitive, and Neurological Factors in Learning. I did break this one up into 2 different videos because there are 2 CED questions with quite a bit of essential knowledge that you need to know for each one. And plus, I'm adding a little more details into these videos because some of my students have said that it would actually be quite a bit more helpful to have more details than just sort of like surface definitions and things like that. So let me know what you think about that. I've had a few people comment, which is really great. I always use the comments to help improve the videos. So tell me what you would like to see or, what you're liking about the videos. That really does help me. And for everybody who's subscribed, thank you so much. I really appreciate it. I'm loving the numbers going up and just makes me really happy. So thank you so much for that. So let's get started. So this is the second CED question for 3.9, Social, Cognitive, and Neurological Factors in Learning. So basically it says, explain how cognitive factors in learning apply to behavior and mental processes. The key terms that we talked about in the first part of the video are the same for the whole 3.9. So I won't go over those again, but you can find the separate video with the definitions and real life explanations for that. So let's get into insight learning. So let's start off part 2 with insight learning. It's a fascinating type of learning that doesn't rely on trial and error, reinforcement, or modeling. Instead, it happens through a sudden realization. It's kind of what we call the aha moment. So let's have a look at the definition of that. Insight learning is when a solution to a problem suddenly comes to mind without needing prior practice or observation. It's a mental breakthrough where the learner understands the problem and figures out a solution all at once. It's that aha. Right? Here's an example. One classic example is a chimpanzee in a cage that sees a banana just outside of reach. After looking around, the chimp suddenly realizes it can use a stick to pull the banana closer. This solution comes to mind without trial and error or watching someone else do it. It's purely a result of a mental processing. So what are the key insights about this? What makes insight learning unique is that it happens through mental processing rather than direct interaction with the environment. It shows that learning can occur without reinforcement, trial and error, or previous experience. So on the exam, remember to highlight that insight learning demonstrates how thinking and problem solving can lead to learning without the need for reinforcement or observation. It's about processing information mentally to achieve a sudden understanding. Now let's have a look at latent learning. So latent learning is a type of learning that's not immediately visible, but shows up when it becomes useful. This challenges the idea that learning always requires reinforcement. So here's the definition. Latent learning happens when an organism learns something but doesn't demonstrate that knowledge until there's a reason to use it. In other words, the learning is stored and only becomes evident when it's needed. Here's an example. Imagine a rat exploring a maze with no reward at the end. The rat moves through the maze, learning its layout without showing any signs of understanding. But later, when food is placed at the end, the rat quickly navigates to it, demonstrating that it had already learned the maze during earlier exploration. So the key takeaway here is that learning can occur even without reinforcement during the process. The rat didn't know that didn't need to learn the food to learn the maze. He just simply needed the situation where the knowledge was useful to show what he'd learned. Latent learning highlights that reinforcement isn't always necessary for learning to happen. On the exam, be ready to explain how this concept shows that organisms can acquire knowledge and hold on to it, even if there's no immediate reward or visible demonstration of learning. Now let's move on to cognitive maps. This is the definition. A cognitive map is a mental blueprint of an area. It's developed as we move through and observe our surroundings, allowing us to navigate later without needing explicit instructions or a physical map. For example, imagine visiting a new city that you've never been to. You're casually walking around without any specific goal. The next time you visit, you find that you can navigate the streets and locate landmarks without needing a map. This happens because you formed a cognitive map of the city based on your prior experience. Cognitive maps demonstrate that learning can occur without reinforcement. These mental representations are developed simply by interacting with the environment, showing that reinforcement isn't always necessary for understanding and navigating. So on the exam, be prepared to explain how cognitive maps support the idea that organisms, including humans, can learn and adapt to their environment through observation and experience, even in the absence of rewards. Let's have a look at some real-life applications of cognitive learning. For example, problem solving. Insight learning can explain how people suddenly solve puzzles or math problems without having tried specific strategies beforehand. Or everyday navigation. Latent learning and cognitive maps explain how you can find your way through familiar areas, like your school or your neighborhood, even if you've never taken that exact same route before. So here's an application tip. Be ready to apply insight learning and latent learning to real-life situations where people or animals demonstrate knowledge without direct reinforcement. Okay, so let's just have a look at the cognitive factors and mental processes. We're going to look at all of the ones we've looked at so far. Insight learning, solving problems mentally without prior trial or error. Latent learning, knowledge acquired without reinforcement, which becomes apparent when needed. Cognitive maps, mental representations of the physical environment, aiding in navigation and problem solving. What's our key takeaway? Cognitive factors show that learning involves more than just reinforcement or association. Mental processes like insight and latent learning play a significant role in our behavior. So let's just finish up part 2 here with our key takeaways for the AP exam. Insight learning occurs without reinforcement or models, showing how mental processing contributes to problem solving. 2, latent learning demonstrates that learning can occur without immediate evidence, often revealed later through the use of cognitive maps. And 3, Tolman's experiment is key evidence for latent learning and the role of cognitive maps in guiding behavior. And that's all I have for 3.9 part 2. I hope you found that helpful. If you did, hit that subscribe button for me. Thank you so much, and I will see you next time.